So my name is Scott Kurinskas. I'm in the products organization at C3, lead platform product management. And with me here is Jeff Fischer, runs the AI ML platform, if you will. And we are here to talk to you about how to unleash the power of the C3 AI Agentic Platform. I want to start by talking about what is an agentic AI application. And more specifically, what does C3 think are the key ingredients for developing an agentic AI application? It starts with data. Clearly, data sets the foundation for frankly, everything we do from an applications perspective. And without a solid data foundation, any derived insights are of questionable value. I'm proud to announce this year at Transform, we're working on two new innovations in the platform: a formalized agentic tool and an agents framework. And Jeff will spend quite a bit of time talking about agents and tools. And then we'll also give you our thoughts about, when it comes to agent orchestration, what do we think are some of the common patterns you'll see? And what are some of the capabilities we're looking to support from an applications perspective? Now, I want to first level set. When I think of a generative AI application, this is typically the user experience you see. A chat. Nothing wrong with it. We've been building chatbots for years. If anyone, OpenAI solidified this interaction paradigm in an application. But I think we can do better. As you're building these applications, whether it's reliability or supply chain, these applications are rich with context, rich with data. So how do I pass that context and that data to an application or to a large language model? So what if that context was automatically available? So instead of having to ask, what is the CPU utilization of the reliability application? If I were to click on that reliability card and just say, what is the CPU utilization? It knows from my gesture, from the application, the name of the application, and the tools can use that to further refine the data that's retrieved and the response that is generated. This is a small incremental step. I think many of you will ask, why do I even need to ask a question? Shouldn't applications be heading in a more autonomous direction? If a failure has occurred, why can't the system, why can't an agentic workflow understand why it's failed and what steps to take to remediate it? Now, I'll be very honest, I'm more of a evolution than revolution person when it comes to applications. And so we're going to start with presenting a user experience, or at least if I navigate to a workflow management page, I can see what are the errors and what are the recommended actions, and then let the user make the decision. But once we get these workflow processes ironed out, it's kind of Jim talked about this morning, I see no reason why there's not a category of failures, if you will, and from a C3 platform perspective, that can't just be automatically recovered or automatically retried. So to me, I want to see applications heading in a more intelligent, more responsive, and maybe autonomous direction moving forward. With that context, at least my vision, my thoughts around applications, what do you need? What are the tools, what are the capabilities that I think are key ingredients for building an agentic AI application? First, data. Without a solid data foundation, as I mentioned earlier, everything you do downstream is of questionable value. Now, the good news is many of you are already on a journey to create, call it a data lake, data foundation, and you're using products and services such as Snowflake, Databricks, and our cloud partners to build, to pull together data from disparate systems and put it into a common data lake that can be reused across applications. We like to sit on top of these data foundations, if you will. But we need to make sure we've got clean, quality data. Once I have a solid data foundation, then it comes down to what are some of the data processing pipelines that are required? And more specifically, how do we move beyond structured but looking at unstructured data? If there's anything that we've learned in the past, say, 3 years, or maybe it's been reinforced, I'll say, is that unstructured data provides much, much more insight to applications than I think we would have ever imagined. Think of the case of reliability. Failure occurs, you have a failure mode library, so you know why it failed. But today, a reliability engineer may need to go to SharePoint, open up a PDF, understand why it failed, and then take action. Well, if the system's going to tell me that something failed, why can't they automatically ingest the manual? So I have the context about the failure and the failure mode, and I can, in the context of the application, say, here's what you need to do to resolve the error. Don't force the user to kind of step outside and go somewhere else to solve a problem when a document or set of documents can help assist them. And so I think moving forward, and many of you probably are experiencing this, unstructured data is going to become a more and more important part. Now, once I have my data and my pipelines, to me now the fun begins. What are the tools, what are the APIs that are needed to automate business processes or business tasks? So to me, a tool, or an agentic tool, if you will, could be as simple as a wrapper above an API, or it could be as complex as execute arbitrary Python code generated by an LLM. You guys can decide the sophistication of the tool. But then those tools have to be part of an overall agentic framework. And so those agents, to me, I'm not going to call them smart, but to me, the role of an agent is to say, here's my goal, here's my objective, here are the tools I have at my disposal, and then it hands all that off to the LLM, the brain, if you will, to make the decisions about how the goal is accomplished. Now, before we get to the brain, I want to talk about context. Because if there's anything I've learned from working on this presentation is that when it comes to dealing with large language models, context matters. Context could be something as simple as an event ID coming from a wind turbine. But it also could be the prompt that is associated with a given agent. And what's fascinating about the world of large language models is, we're now starting to blend structured programming with natural language. Tools and agents may be authored in, or tools may be authored in Python, a structured language, or I can just describe a task so that the LLM can generate the code for me. But the importance of prompt and prompt engineering is something that I know it's been widely talked about in the past couple of years, but it's really, I think, going to change the way we think about programming. And especially if you're going long on Gen AI, the importance of those prompts becomes very, very important. And then there's the brain, the large language model. Makes the decisions as far as how to achieve a particular task, given the tools that have been provided to it. And now we get into some interesting areas around security and guardrails. Now, what's interesting is if you think about building an enterprise application, all of the security requirements that you used to have still apply. You still need access. You need role-based access control to data, to APIs. You need a secure software supply chain. You need to run CVEs to make sure there are no critical vulnerabilities that you're injecting into your production environment. But now, agentic applications have a higher level. How do I present hallucinations? How do I make sure that the data I'm returning is factual? Because now it's not necessarily coming directly from an API. It's going to go from an API to an LLM who may reason over it and may or may not make the right decision. So adding guardrail and content filtering support will become table stakes moving forward. And then, of course, there's the user experience. That could be a chat experience. It could be a rich workflow-enabled application like reliability or demand forecasting. You can decide. And then lastly, and now I'm getting into the platform weeds, what about observability? Observability requirements, I'd say, have changed. You still need to understand what actions are being performed. You still need that audit trail. But you're going to want to take a look at how is the LLM behaving? How is it reasoning? And you're going to want to keep a trace of what are the decision points so that you can go back and maybe fine-tune your agents, fine-tune your tools if the responses are incorrect. So how we think about observing the behavior of an agentic application is going to require additional work, additional tools. And so, the way I think of it is, in my time at C3, my role and my team's role really is to deliver the tools and the platform capabilities to enable you to develop, deploy, and operate large-scale enterprise AI and now agentic AI applications. Just to be clear, our goal, we're spending a lot of time talking about agentic AI at this session, or at Transform this year, but traditional ML, which is kind of crazy given it's all of like 3 years ago, is still a critical part of what we do. So providing a platform that can support generative AI or agentic AI with traditional ML concepts like classification, logistic regression, deep learning, so I can do image recognition and classification, is paramount. So we're trying to provide an application that can support the end-to-end application development and data science stack. And it's constantly evolving. 2 years ago, you wouldn't have seen vector store on this diagram. You wouldn't have seen large language models. You wouldn't have seen LLMs. We've had to evolve the platform, and we're going to continue to evolve the platform. There's a lot of really interesting work going on around observability that you'll see starting around May 20th. So I mentioned the 3 pillars that we're going to talk about today: data, tools, and agents. Well, 4: data, tools, and agents, and orchestration. I'm going to talk about what we call omni-modal data fusion. It's a really fancy way of saying structured and unstructured data integration. And each one of you in your organization have data in a wide variety of sources. Could be databases, historians, file systems, document stores, streaming systems, or API data feeds. Each one of these systems will have data in a different format. It could be relational, it could be compressed time series, it could be an image, a video, or documents of various flavors. If you look at the types of data you're going to need to deal with, it's going to be wide and it's going to be diverse. And as a result, you need a flexible platform, an extensible platform to build both structured and unstructured data integration pipelines. If we were having this discussion 3 years ago, it would have been a very structured data integration discussion. How do we ingest time series data, asset data? How do we connect to historians, and so on? But the importance of documents has come to the forefront. And what's interesting is that the processing steps remain largely the same. If I'm going to ingest data, typically from our workflow perspective, I need to chunk it or break it up into pieces. I need to transform it, and then I need to persist it. Documents go through a similar process, and if it's just a PDF, I can chunk it, I can generate an embedding, and I can store it in a vector store. Easy peasy. But what if, and this is where life gets interesting, those documents have, or those PDF files have a table that I want to actually extract not just the PDF the textual content, but the content of that table. And I want to store that. Now I almost have like a pipeline within a pipeline. I need to understand the structure of the PDF. I need to understand where does a table, how do I identify a table in a document, and how do I extract that data? So these pipelines, from an unstructured DI perspective, can get significantly more complex, but the value they can deliver downstream is immense. And ultimately, one of the prerequisites and objectives of the platform is to help you build this application ontology or this application data model. To me, we go through this effort, we go through structured and unstructured data integration to really help you build an application data model that can power your business. So this is a trivial example of wind turbine, but if you were to look at the reliability data model, the supply chain data model, it would be significantly more complex. So now that we have that structured, we have the data foundation, what I want to do now is hand it over to Jeff to talk about the new innovations in agentic tools and agent integration. Jeff.
Thank you, Scott. So I'm going to talk about tools, agents, and orchestration. And not to scare anyone, I'm going to show you some code. And the point, so don't all leave the room right away, but the point of the code is really to show you how simple this really is. It's not magic. It's really kind of building kind of simple layers on top of your existing systems. First, let's talk about tools. So what is a tool? A tool is an atomic function used by an agent. So you can think of it as a function call in Python or JavaScript. When the agent is initialized, it's given a list of tools, and it's given some metadata describing how to use these tools, and we'll see that, an example of that. In C3, you can now write tools, and you can write them as either native Python or as C3 actions. Okay, so I'm going to give you, walk you through a simple example. This is the Python code for a function, and this function returns events for a turbine. It has a couple of parameters. It takes a turbine ID, start and end dates, and an optional event code. So there's about 10 lines of code here. It's going to query your data model and return kind of the requested data. And you can see I can call it, I can define it in Jupyter, I can call it in Jupyter, and you can see the format is pretty simple. It's a JSON-like format that LLMs can easily understand, and you see the records that were requested. Okay, so now I want to take that simple function and make it available to my agents as a tool. So to do this, there's two ways to do this, as I mentioned. So we'll do the native Python version first. So what we will do is we will add annotations to provide additional information to the LLM. And this approach is pretty standard. So like, for example, the AutoGen framework from Microsoft does the same thing. And so there's this annotation. And so every input parameter and the result are annotated with a type and a natural language description describing what that parameter means, right? And then there's finally the type documentation for the doc string for that function, and that gives you an overview of what the function does, and like other information you might give that are not really encoded in the types, like the event codes, what they mean. And so the natural language is helping the LLM to understand how to call this function. We can do the same thing using C3 actions. So we take that Python function and we make it a type. So we make it an action. We have a type called wind turbine tools. It has one function called get events for turbine. It has the types that basically correspond to that signature you saw on the last slide. And the exact same documentation formatted as what we call type doc in C3. So this is got a standard C3 development. And this means like all the actions that are used to build our applications are available as tools for building agents. Okay, so the final step is we need to tell C3 this is a tool, so there's an API call to register this as a tool, slightly different in the two cases. One, you give it the Python function in a file, the other you give it the type and the action name. So that's all we need to do to create a tool in C3. Okay, now let's talk about how we use these in agents. So the first question is, what is an agent? So an agent is a system that accomplishes a task on your behalf. That's pretty general. And an agent is going to involve probably a human being or something calling that agent. It's going to involve an LLM, which will be used for planning and maybe other reasoning things. Memory, so memory is that if it's dynamically planning what it's going to do, it needs to know what's already happened. It also may need to know about past questions the user asked and what those answers were. And finally, we have a collection of tools. And so like for your application, you can decide what tools you need to give that agent to answer the questions you anticipate from the user. And the tools are really the way the agent will interact with its environment. And I also mentioned that kind of from a deployment perspective, all these pieces may be living in different places. So typically, the LLM may be running in the cloud somewhere. The tools may be running in the context of your application. And like with C3, the tools that they're running in your application, then they have the same access controls and kind of enterprise security that you would expect for an enterprise application. So then we basically initialize our agent with the LLM memory and tools. The agent then will build prompts for the LLM, and it basically mediates all the interactions between these places. So as an example, the agent may send an initial prompt, and the LLM may come back and say, call this tool for me, here's the parameters. So the agent then will call the tool, and then take that response and pass it back to the LLM, and ask the LLM for the next thing to do. And so that's kind of the main loop of most agents. And so it's really acting as a mediator here. Now the LLM is really doing the planning in most cases, but the agent can intervene as well. So for example, you may want to have a limit on how many interactions totals. So it, depending on the kind of question, you don't want it to go off on some open-ended boondoggle, right? Another thing might be that you have a data retrieval function, a tool, and you don't want it to return too much data, so you can inspect the query parameters passed before they're sent down to the tool. And if they're too broad, you can send a response back to the agent saying, to the LLM saying like, give me a more precise query because that one is too broad. Anyway, and so that's basically the basics of what an agent is. Okay, and in our framework, so if you go look, there's like many agent frameworks out there, new ones every day. And we kind of decided at C3, we don't want to build yet another agent framework. We want you to kind of figure out what makes the most sense for your business, and we'll kind of see how this kind of world plays out. And so our goal is to kind of integrate kind of natively with any kind of the popular agent frameworks. So here's an example using LangChain's agents. So we can basically convert our tool representation to the representation that LangChain needs for tools. And then the LangChain agent needs an LLM. We have APIs for calling all the popular LLMs. So here we're going to instantiate a connection to an Azure OpenAI LLM, pass in a particular model. The authentication is managed by the C3 platform. So then we can instantiate this agent, giving it the LLM, the tools, and the system level, the system message, which are the instructions for the LLM, for the agent. And so very simple. Okay, and we support so out of the box today, we support LangChain and Llama Index, and it's like a few lines of code, because we really have all the information that any of these frameworks would need to know how to call a function, and so we can translate it to whatever schema or whatever format they want. And it's a few lines of code to do that. Okay, now I'd like to talk about orchestration. And orchestration in the context of this is really managing and coordinating multiple models and workflows and tools and things to achieve complex tasks. So all these things that we have, how do we put them together? And so the first way you can do it is what I would call deterministic orchestration. And so this is an example. You may have heard about the C3 AI Code Assistant. I hope you try it out. And this is kind of what's happening behind the scenes. It's a deterministic orchestration, probably like 20 lines of Python code. And you can see a query comes in, there's one decision point in the flow. We need to decide, is it a new conversation? If so, we create a new session. Otherwise, we're going to retrieve the history of questions and answers from so far in the conversation and call an LLM to rewrite that history, and basically so that we can kind of answer follow-on questions. And either way, we pass that down to the next step. We retrieve then relevant documentation from our vector store. We've chunked the documentation using GenAI, and then we pass that out. We combine all that together with a prompt, and then we have a question answering LLM, which has been fine-tuned on C3 code, and then it can give you an answer on like, how do I create a Lambda feature set? And so as you can see, this is all deterministic. There's only one decision point. The flow is fixed. Other than that, and kind of the only non-determinism in your answers is really coming from the LLMs. Okay, now here's sort of the same use case, but in a non-deterministic manner. So here I've created an agent. it's going to solve the same kind of problem. I want to ask questions about C3 code and use the documentation and my fine-tuned LLM to answer them. And so there's now one new thing, which is this planning LLM. So rather than having the fixed structure, the planning LLM is going to basically figure out dynamically what's the next step. And so we will, then we have the reflection LLM and the memory. Those are basically the question rewriting part where I take the history and rewrite it so that I can answer that question, the context of that history. You can see now semantic search is now a tool, and the question answering LLM is also now a tool. So with all that, the agent can then take a user query and answer questions. And because we have this dynamic planning, it allows a lot of additional capabilities. So one is that we can build a code validation tool, and then we can say when the question answering LLM comes back with some code, we can validate it through the code validation tool. And if it doesn't pass the validation, we can actually send it back to the LLM saying, here's the code you gave me, here's what's wrong with it, go fix it. And this actually works, at least a good percentage of the time. And I think in our overall results, we saw like a 10 to 15% bump in quality of results of questions we can answer, arbitrary questions about C3 things. So it's a very powerful concept. So here, so same use case, but non-deterministic rather than deterministic. So you can also mix non-deterministic and deterministic orchestration. So this is an example. This is maybe I have a anomaly detection application as part of asset management. So there's a workflow that I have that's deterministic. And so the first step I have is there's some triggering event. I'm going to fetch the latest features. I'm going to call an anomaly detection model. And if there's no anomalies detected, I stop there. Otherwise, I will call an explainability model and determine feature importance. And then I will take all that information and feed it to a root cause analysis agent. So that's non-deterministic within that step. And that's going to take the information that it has and try to determine what is the physical cause of that anomaly, right? And then once that is done, then we can pass all this to an evidence package agent that will try to gather all the information it has, plus things from the documentation and other places, and build like a contextual report on this anomaly and what we think caused it, and here's all the documentation. And then at that point, we can give an alert to the user. So you can see here, we're combining both deterministic workflows, non-deterministic agents, as well as traditional machine learning where we have like maybe a supervised or unsupervised learning model there. Okay, so I will show you a demo to make this clear. Okay, so here I have a simple wind turbine application that I've augmented with the agentic capabilities. So I have a list of wind turbines, right? And I can ask like, what is the distribution of event codes for March 2025? And so what it's doing in the background is it's sending this to an agent running in C3. That agent will then run a number of tools, and that resulted in a pie chart that's showing you the distribution of these event codes for this month, right? And so, and then, like I said, it's combining the results of 3 tool calls to provide that information to us. So we can also drill down. So this is showing you the information for a particular wind turbine. And so I can click here and say like, describe this turbine, right? And so now it knows that I'm on turbine 1. So it'll answer that question in the context of turbine 1. I don't have to type that. And so you can see it gave me a high level description as well as like an English summary of that, right? And then I can also click on a particular event and say, describe this event. Okay, and so this again will go out using the context of the turbine and the event to answer the question. And so in this case, you can see it gave me a high-level description of the event. It also went to a semantic search tool and grabbed relevant information. So this was, the event code was M4, so it says M4 is about tightening lug nuts. So it's very important to tighten lug nuts. So here's a description from the manual on how to do that. Okay, and now we will try to switch back to the slides. Okay. Okay, so let's see how that worked behind the scenes. So we have our UI, right? And we have an agent, we have LM, we have tools, right? So the UI asks the question, what is this event? And we have the context of a particular turbine in a particular event. So the agent then will build a prompt for the LLM, and it will send that to the LLM. And the LLM will respond back saying, oh, I want you to call a tool. That tool is get event info, so the agent will call it. And so it'll pass in, the LLM knew that from the context that it wants information about event 234. So get info will get that. Then we have, it returns the record for that event with including a description. And so the agent then passes the response back to the LLM. The LLM now comes back and says, call another tool. And that tool is going to be the semantic search tool. And you can see basically the gear oil overheat phrase, it pulled that from the description that was in the first response. So it knows how to tie together kind of the kind of inputs and outputs of these tools. And then that will return a list of relevant passages from the manual. And so the agent will pass that final response to LLM. The LLM will decide that it has enough information to answer the original question. So it will return a markdown formatted response answering that question, including all the information. So then the agent will then pass that back to the UI and say, here's your answer. So anyway, that's what's happening behind the scenes. So you can see it's not that complicated, but it gives you a lot of power in what you can do with your applications. Okay, so in kind of summarizing our talk, kind of building these complex agentic AI applications is difficult, but increasingly you need this flexibility and adaptability. So we think kind of having a solid foundation of the data integration, data modeling for both structured and unstructured data is a key component so that you have the stuff to answer that the agents can use to answer their questions or to perform unsupervised tasks. And finally, obviously, a robust, extensible agent and tools framework is essential. Thank you. Any questions? Yes, you can come up to the mic.
In the set of agents that you've built, you showed a flow where the agent has to interact, back and forth with the LLM, right?
Yes.
To go back, understand context, and come back. So instead of that, why can't we have a master agent that understands that context once for all, and then works with all those other agents, like your object-oriented agents, to get an answer and then send it directly to the user interface? So why that? Can you avoid that back and forth with that LLM, and then just have that master agent to orchestrate amongst all?
So in terms of why does that one agent have to go back and forth? Because that's how the agent itself is implemented. So the agent is basically just this layer, this coordinator that sits on top of the LLM. It doesn't have the ability to do the planning, and the LLM doesn't have the ability to call the tools directly. So that's why they need to go back and forth. Now you could take that agent and view that as an abstraction, and then have other agents call that agent, and those, right, the caller will not be aware of the detail of the internal communication that's happening.
Okay. Thank you.
And most of these agent frameworks you see out there, they're basically doing that back and forth for you. But it's pretty simple. It's like 20 lines of Python code in my agent. So, yes?
How are you dealing with hallucinations on terms of data, that the agent doesn't invent any data and presents it in a wrong kind of way?
That's a good question. So There isn't one answer for that, and that's one problem when you build these things. You think you have something great, but you have to really check the answers to make sure it's not making things up. There's a number of strategies you can use, and kind of that's kind of where it gets more complicated. I mean, like one is generally these LLMs are not very good with math, so you want to have specific. If you have more specific tools, they're less likely to hallucinate answers. Another one is like doing validation. So like I showed you with that code, with the code assistant, basically sometimes the model will hallucinate APIs that don't exist. And so then you do the validation of the answer and can come back and ask the LLM to fix it. And the worst case is you just tell the user, I can't give you an answer to that, right? Another strategy is that you basically you have the LLM report back kind of what was the thought process and what was the sequence of tools, or the agent, not LLM in this case, but what is the sequence of tools? And that's like the next version of this demo. I want to like have a little button you push and it shows you what it did. Because I think that gives you abilities. If you aren't sure about the result, if you see what it did, then it can, validate. You can validate that manually by looking, or at least look at it and see if it makes sense. If they're like numbers that there's no way they came from those tools. Oh, and the last way is there are approaches where you can have LLMs validate the outputs of other LLMs. So you basically have the LLM produce an answer, and then you can give it to another LLM and ask it, does this, in the context of this evidence, does this make sense? Yeah.
Nice presentation, nice tool. Like it. Question is on the validation. Do you have a sandbox where you run the code, or you have a different framework?
So in this particular, so you have the option in C3 to do it different ways. So like in this case, there's no code that is being executed directly by the LLM. I only give it tools. And so the idea being there that then it really, and all these, I know these APIs are not dangerous, right? The worst they could do is return too much data. And again, like I mentioned, you can have safeguards around that. So by designing kind of your agents and tools, you can ensure, right, that there's nothing dangerous that can happen. I know that the Gen AI the Gen AI application also has like a Python sandbox they use for running Python code, and most of these agentic frameworks have some kind of sandboxing they do. Sure. Any other? Okay.
How easy it is to set up an agent? Time consuming, and once the tool is available?
It's pretty easy. I mean, so you saw like the code to set up like an agent, and if you pick an existing framework,
Yeah.
then basically it's like 3 lines of code, right? And then
Okay, so with that in mind, you guys plan to incorporate, in particular for reliability, the inference workflow that you mentioned in one of the slides?
yeah,
Is that being planned to be incorporated as part of the base of the application? Because that will really help in vetting the alerts.
yes. I mean, I believe they're working on some form of that.
Yeah.
I don't know the exact details of what they're doing, right?
Yeah.
So I mean,
As a code, right? So
yeah, I mean, as a platform PM, our goal is to kind of provide both our customers and our applications all the tools they need to build these things, tools in the more general set, not just tools. And then, the applications, and you can take advantage of that. And, I believe they have in mind doing these kinds of things. And I think it's the natural, progression for this.
yeah, it has to, right? Because
Yeah.
otherwise it's kind of disconnected.
Right.
All the 131 applications without leveraging this
Yeah,
type
yeah,
of,
yeah.
capability.
So, and part of, this exercise is that, we're trying to say, these are some standard ways you can use for building these agentic applications, and then the various application teams can take advantage of that and build that into their apps.
Yeah. No, thanks.
Sure. Anything else? Hey, thank you.